Hello, this is Mr. O'Brien, and this last lecture of Unit 1E will be about the periodic table. This is part one of two, and we'll talk about section 6.1, the information that's present in that textbook. So let's get started. So the periodic table, as we know, is not just a poster, a cool poster, or an iconic image of chemistry. It's actually an instrument, a tool that chemists use, and even I use it still to create solutions. And there's a lot of information that can be derived from the periodic table. And you probably already have some exposure to using the periodic table to pull out some information regarding, say, the Bohr model, right? Energy levels or orbitals in a Bohr model of any atom. So let's get started with what we already know about the periodic table. So we know that the elements are ordered by the increasing atomic number, right? So the number of protons increases from left to right on the periodic table. We also know that the periodic table is divided up into what we call periods that go left to right. They are essentially rows, and groups that go that are the columns that go up and down, right? Now, the difference between the periods and groups, well, we kind of had an activity in which we identified that the periods, the elements, are like essentially friends. And the groups were what we dub as families, right? And the difference between family and friends is that within the family, you're going to have individuals or the parts of the family that are most like each other. There's going to be more characteristics of elements within the family than the elements that are in the same period. They're going to have some characteristics, but they're going to be less characteristics. They're going to be less similar than the ones that are within the family themselves. So because there's this families and friends idea of the periodic table, we have names for certain important families. So first one we call the alkali metals. And then we have alkaline earth metals. And then your lanthanide series and actinide series, which are here at the bottom, these are also dubbed the rare earth elements. They're kind of a combination of radioactive materials with man-made substances, usually found combined in nature with other elements. Then we have the transition metals, which we kind of talked about before. And we have a new group called the metalloids, which we'll talk about that later on in the lecture. And we have the halogens and the noble gases. Now, we also know that the periodic table has numbers associated with them. We can identify, say, like, all right, this is period 1, that's period 2, that's period 3, that's period 4, and period 5, and so on. These are the rows, the friends of the periodic table. And we also know that we can identify the groups by a certain number as well. So this is group number 1, this is group number 2, group number 3, and all the way down across to group 18. But we also can identify these groups by another code. We call this the A code, 1A, 2A, we'll skip across here, 3A, 4A, 5A, 6A, and 7A, and 8A. And if you don't know what these little letters mean, these are Roman numerals. So in this last one, this is the Roman numeral for the letter, for the number 8, V3. And so when you get to this point here, the V stands for 5. The one IV, meaning 4. The one before the V is 4. And then this section here is dubbed the B group, right? So different ways to kind of code the periods and groups of the periodic table. Okay. And important to note as well is that there are two elements that are two groups of elements, families of elements that are extremely reactive. And those groups of elements are the alkali metals and the halogens. And there's a group of elements that are extremely not reactive, that they do not bond or hook up with any other elements, and these are the noble gases. The noble gases are very unreactive. And you might be wondering, if you're questioning, why are they reactive or not reactive? And those are ideas that we'll hit up later on in the second part of the lecture. It's just important to know those right now. All right, so let's move on, right? So we can classify elements into much broader scope, right? A much broader brush. And we can classify these elements into what we dub metals, nonmetals, and metalloids. So it's kind of like saying that, hey, the Santa Fe High School, we have freshmen, we have sophomores, we have juniors, and we have seniors, right? With all those 2,500 plus students that we have, we can divide them up into 4 categories. And the family idea was the fact that within the group of sophomores, right, that are unique from each of these, we even have unique subgroups like, ASB guys, or like baseball, or soccer, or band, or other academic groups. So we have this idea of classifying in a much broader scope, and then we subdivide them into much smaller groups that are more similar, right? So let's continue on with this idea of what are the metals. So majority of the elements on the periodic table are dubbed metals, and they are elements that are shiny. They are malleable, which is a term that we describe as bendable. They're excellent conductors of heat and electricity, meaning that they can move electricity and heat from one place to another. It doesn't mean that they make it, they can just move it. And then ductile means that you can put them into wires, right? Examples of some metals here, obviously, are the picture at the bottom. The non-metals are an interesting group as well. They are the opposite of metals. So these yellow area here are elements that if they are solids, they're going to be dull. They're not going to be shiny, and they're going to be brittle, meaning that they're going to break. They're not going to be conductive, meaning that they're going to be non-conductive. You might have noticed this when, like, say you have a frying pan, and your frying pan has like a handle on the frying pan, and that handle is usually made out of wood or some sort of rubber material that does not conduct heat or electricity. It doesn't make anything hotter. Interesting to note that the nonmetals actually contain mostly gases. All these ones here, this last column, as we dub the noble gases, they are gases, and here's some more gases. So we have a few solids, right, at room temperature, but we have mostly gases. And then we have another unique group that I just described before called metalloids in the previous slide. And this is kind of like a group of elements, a family of elements that have like mixtures of both properties like metals they can conduct electricity, but they also have properties of nonmetals in which they might be brittle. And these types of elements are kind of used in computer chips because they have properties of both, right? Then we have a section that we call the representative elements, which we dubbed already called the A group, right? And then we have, and these A groups essentially are organized by what we eventually will find out is the valence electrons, okay? Last piece of note about this picture here in most periodic tables is that they have a staircase line that divides up the metals from the nonmetals, and anything that really touches the staircase line is dubbed your metalloid, except for aluminum. Aluminum is that little exception there, okay? So let's practice using some properties to compare or to identify the location of certain elements. So in this example here, a period 3 element is a gaseous element and a poor conductor of heat and electricity, and it is extremely non-reactive. Where would this element be located on the periodic table? So let's start breaking this up and show you some tips. So try to find the hints. So one of the hints is that it's period 3, right? So it's not 1, it's not 2, it's not 4, it's not 5, it's not 6, not 7. It's period 3. So it's somewhere here in this realm, right? In this row of friends. It says it's a gaseous element, so it can't be a metal. So there's another hint here. Can't be a metal. And it's a poor conductor of heat and electricity. So it could be somewhere in this realm right here. Right now, silicone does conduct electricity. Now, how poor is it? It's kind of like a subjective idea, but we'll find out. And then it's extremely non-reactive. That means it doesn't hook up or bond with any other elements. So those non-reactive elements are here in this noble gases. So we're only left with one choice, which is argon. And so it's essentially that's how you identify the elements based on those the properties. So try this with these two questions, and if you're having a hard time, hit me up in tutorial. Okay. So we saw a video about Dmitri Mendeleev, which is he's dubbed the father of the periodic table, and it's not because he made the first list or the second list or that he organized elements, known elements at the time. It's the fact that he noticed that there's got to be a list in which a repeating pattern occurs among the lists of characteristics. And this is an idea of what we call a periodic law, a repetition of chemical and physical properties. He's giving credit to the modern periodic table because he left blanks in his original periodic table that allowed for these elements that were unknown to him at the time to be placed there when they would be found. And so again, he predicted a whole bunch of elements that wasn't known at the time, just based on this idea of repeating patterns of characteristics. So using that idea of periodic law, we can extract a lot of information about elements. One of the things we can extract about is this idea of the type of elements and its characteristics. So we know that the metals are on the left-hand side of the periodic table, and as you go to the right, they become less metallic and more non-metals, right? And there's other characteristics that we know that we'll eventually talk about in the second part of the lecture. We also know about the amount of valence electrons present, right? It's an idea that we learn about from the Bohr model. And we also know a little bit more about the size of the element's atom or ion. And again, an idea that we kind of already explored when we hit up this idea of the Bohr model. And an ion, different from an atom, remember that the atom contains the same number of protons and electrons, so it equals neutral. But an ion is when we have more or less less electrons, more or less electrons. So we have an uneven amount of electrons, right? Which eventually gives us like a charged ion. We'll talk more about that later on. So again, how are we able to predict this stuff? Again, it's periodic law, right? There's patterns that exist within the period and group. So let me show you that idea here in this example of a density graph of values listed around amongst some of the elements on the periodic table. If we divide this graph into period 1, right, and period 2, okay, and then period 3, right, we'll find out that there's might be a pattern that we can see that's similar amongst the periods, right? We kind of had this idea also in the first couple weeks of school. We did an investigation on density. But let's be more clear. Let's find out now what the group pattern is like. Well, I'm going to use another color here, and I'm going to find the alkali metals. And remember, the alkali metals is your group 1, right? So lithium is an alkali metal, right? And we also know that sodium is an alkali metal, right? And we also know that potassium is an alkali metal. If I just look at the X's that I drew here, I notice that they kind of increase. So the next alkali metal on the periodic table, if you have one available to you, you'll see it's rubidium. So where would rubidium be? Well, based on this pattern, rubidium will have a higher density than potassium. And the same thing can be done with the alkaline earth metals, for instance, the group 2A. So here's beryllium, group 2A. Here's magnesium, group 2A. And here's calcium, group 2A. This is weird because now it seems like these guys start to drop in density, right? And so again, you might be able to predict what the next alkaline earth metal down the group would be with strontium, which might be less dense, right? So these are patterns that you can take a look at based on an idea of periodic law. So here's another example of melting point characteristic that we can attempt to predict based on the graphs and the information already provided to us. So if I break this up into period 1, period 2, and then period 3, okay, I'll find out that there might be a pattern that I recognize here. It seems like if you notice here that the metals will always have a higher melting point than your nonmetals, right? But it seems like then the metals melting points drop with after each period, right? And this is kind of weird, right? How these two kind of increase, because as you go down the group, remember that if you look at that periodic table, we have the gases here, right? But as you go down, those gases then become more solids, right? As we looked in the first slide of today. Anyhow, if we look at the question is asking us to order the alkaline metals by increasing melting point. So meaning that it wants to know what the highest melting point of these three groups are, right? And what would these three elements, and what would the lowest melting point be of these three, right? So if we can try to look at the alkaline metals, we know that here is one of them, lithium. Here's another one, sodium. And it seems that the melting point drops. So if the melting point drops, then the one that's going to be next in line is going to be potassium, which is K, right? Once you have K, which will have a higher melting point, then you're going to have rubidium, and then you're going to have cesium, and then you have francium, which will be the lowest melting point based on what this graph is telling us. And this one will have the highest melting point. So based on that information, I can order these three around to be like this. So this will be the highest melting point, right? Then this will be the next melting point, and then this will be the lowest melting point of them all, francium, right? So try this idea out with these questions here. See if you can kind of figure this out. And if you have a hard time with these questions, hit me up a tutorial and we can go on from there.